Alright, let's look at a problem which will end up having a slant asymptote. This is number 44, and the instructions tell us to find the intercepts, asymptotes, use limits to describe the behavior of the vertical asymptotes, and analyze and draw the graph of the given rational function. So we have k of x equals x squared minus x minus 2 over x minus 3. So the intercepts will be at a couple different places. Like to find our x-intercept, that's where we plug a 0 in for y, because it's opposite like that. And so if I think about where this fraction will equal 0, that's really where the top of my fraction equals 0. And then let's see, hopefully we can factor this, because that would be convenient for us to solve. So let's see, x minus 2, x plus 1 is this factored. And so the zeros here are, that's not really what I'm doing right. So x equals 2 and x equals negative 1 are our two x-intercepts. Our y-intercept happens when we plug in a 0 for our x's. So 0 squared minus 0 minus 2 over 0 minus 3. Well, that looks like 2/3. So y equals 2/3 is where our y-intercept is. So that's the first thing it asks us. Then it asks us for asymptotes. Well, my vertical asymptote happens where the bottom of my fraction equals 0. X minus 3 equals 0 when x equals positive 3. And then it asks us to use limits to describe that, which is where we say, okay, the limit as x approaches 3 from the positive direction of my function, which is kind of long, so let's just write, well, our function is not f of x. Let's just write what our function is. It's k of x. So as I get closer and closer to 3 from the positive direction, like 3.01, if I plug that in up here, then I get something a little bit bigger than 3 minus something a little bit bigger than 3 minus 2. Okay, so that will be, those will basically cancel each other out almost, leaving us with a negative number. And then something a little bit bigger than 3 here gives me a positive on the bottom. So a negative over a positive means this will be negative infinity. Then the limit as x approaches 3 from the negative direction of our function, well, if I plug in something like 2.99, this will be a little less than 2 minus a little less than 2, which will cancel each other out, leaving me with negative 2. On the bottom, 2.99 minus 3 would give us negative something. So a negative over negative gives us a positive. So it'll be positive infinity. Okay, so now the only thing left to do is look at our horizontal asymptote, which, if we think about the rules, if our degrees are the same, then that's where we take the leading coefficients, and our horizontal asymptote is y equals whatever that number is. If the degree on top is less than the degree on bottom, that's where we have a horizontal asymptote of y equals 0. But if the degree on top is bigger than the one on bottom, we actually don't have a horizontal asymptote, we have a slant asymptote. Here's how we find our slant asymptote. We do some long division. Okay, which technically, as long as there's nothing in front of my x in what I'm dividing, like this, we could use synthetic division on it and still end up with the same thing. But let's make sure we know how to do long division, because if there's anything in front of x, then it's easier just to do long division. So I am going to do, what I'm going to say is, what do I multiply x by to get x squared? Well, that would be an x. So x minus 3 times x gives me x squared minus 3x, and this is where we change our signs. because we're subtracting. Okay, we subtract those. That gives me a negative x squared plus 3x, which is 2x minus 2. And then I would say, what do I multiply x by to get 2x? I multiply by plus 2. So that gives me, if I multiply back through, 2x minus 6, but then I have to change my signs because I'm subtracting. So negative 2 plus 6 gives me 4. So my remainder is 4, but with a slant asymptote, all I care about is this part right here. I don't care about my remainder. There is a slant asymptote at y equals x plus 2. Okay, and it's a slanted asymptote because if we think about the equation of that, the graph of that line, y equals x plus 2, that's a slanted line. Okay, so now we've done everything they asked except for drawing the graph of the given rational function, which we're going to use all this different stuff we just found to help us draw it. Alright, let's think about our vertical asymptote. Was that x equals 3? So that's right here. There was a slant asymptote at y equals x plus 2, so that starts at 2 and is a diagonal line where I go up 1 over 1. So that looks approximately like this. Okay, so this is going to look a little bit different than what our normal reciprocal function looks like. What else do we know? We know that our x-intercepts are 2 and negative 1. So at 2 I go through, and at negative 1 I go through. Well, that implies that right here my curve does this. Okay, where it turns around at some point. Okay, but that's where this graph is between these two asymptotes. The other thing that also implies that is our y-intercept we said was y equals 2/3, right there. Okay, so to figure out where the other part of our graph is, here, here, or here, well, hopefully we all know it'll be up here because they're almost always, if not always, opposite of each other. But just in case you didn't know, well, we don't have any more x-intercepts, which means I can't intersect here, I can't intersect over here. I also don't have any more y-intercepts, so I can't be up here. This up here is the only place I have left. So that's where my graph is. And we could also plug in some points, like we could plug in 4 and we'd get something that was up here, and that would let us know that that's where our graph is. Okay, but the way we find slant asymptotes was we did that long division to see what is the equation of the line of our slant asymptote. Okay.